Hello everyone, welcome back to another session by K21 Academy. Today our expert trainer will be talking about observability and telemetry. So let's get into the video.
Let's talk about observability. Okay, in the observability, right? So observability is often used synonymously with monitoring, but monitoring is only one of the subcategories of cloud native observability and does not do justice to its scope. Now, so see, you know how important the monitoring is, right? What is the purpose of monitoring? A monitoring is a software which constantly monitors the resources, and if something is abnormal, that monitoring tool will alert back to the system, and from there we will try to figure that out, or we'll try to fix the issue, right? So observability is something like monitoring, where it's a subcategory. The monitoring is one of the subcategory of observability. Okay, so where we will try to observe or monitor the resources on the Kubernetes platform. Okay, now whenever you're monitoring the system, right, you need to monitor each and every aspect of your platform. Let's say yesterday we have seen the Kubernetes resources, right? Like replication controllers, deployments, pods, services, routes. All these things are the resources. So you need to observe all of these resources in a cloud native environment. Okay, now, when you monitor this, right, each entity must produce appropriate data to support automated problem detections. So I can give you a simple example of uh, one example that we have discussed yesterday. We have talked about HPA, right? Horizontal pod autoscaler. What is the purpose of HPA? You can, whenever the application utilization, when it reaches its threshold value, right, immediately it will add more resources or more pods. So how the Kubernetes has know that it is falling short of resources and it has to add one more pod? That is because of the monitoring system, because of the metric system, the data it produces, the data it gathers, right? Based on that, it will come up with uh, you know a conclusion that yes, this application need to be scaled up. Or if the application is underutilized, then it will assume that it will conclude that yes, I need to remove some pods because the application is underutilized. So automatically the self-healing capabilities will come into picture if you have this observability monitoring in place. Okay, now, so what kinds of data should a service produce to be observable? Okay, so now what are the things that the system has to observe? That is health checks. Often you have to check the health checks, especially the HTTP endpoints. Whenever you have web applications, right, you have to check the HTTP endpoints health checks. Okay, like your Kubernetes or Cloud Foundry or Cloud Foundry platform, especially used for the orchestration system. Okay, the health checks plays a vital role in your observability. And similarly, you have to have metrics. So metrics also plays a major role for your automatic scale up and automatic scale down. Okay, so whatever data it collects, right, it stores the data, and based on that metrics it can take a decision. Okay, okay, and then log entries. Again, logging is also important. So whenever you perform any activities on a cloud native platform, logging is essential. From there the logs will be pushed to centralized logging system, and from there the developers can identify the issues reported from the application. That will be a kind of a feedback to them, and based on that logging and feedback they can enhance the applications as well. Okay, so that's how the logging will help you to debug. Not only for developers, the logs will also help as far as infrastructure activities are concerned. Let's say if a node is down, you will come to know only when there is a logs for that particular activities. Let's say if the node is down because of some, you know, disk usage, I mean, maybe the slash on the server might be reached to 100%. So you will get that information only from the logging. So logging plays a vital role, especially for to come up with a root cause analysis. Okay, so that where the logs will help you. And the next one is distributed request or end-to-end tracings. Okay, now yesterday we have seen a diagram, and a pod a life cycle diagram, right, where your API will talk to, where we have seen your API will talk to, uh, you know your scheduler will talk to API. There is back and forth communication which happens between each of these services, right? And that end to end flow, right, you should have the tracking for that particular end to end flow. So we have seen yesterday, right, whenever we want to create a pod, what happens at the back end? It The request will send to API will check the authentication authorization. From there it sends the request to scheduler then sends the request to kubelet will send the request to docker will create a pod. So this entire life cycle, right, starting from the API server to create a container on a using docker is a set of processes. So this entire end-to-end tracking should be available, so that if there is any break between this system, it will be easy for us to track those issues. So that tracking should be available for the observability. So the observability has all these features. So health checks, metrics, logging, and end-to-end tracing. Okay. Now, so observability. So what? So you have seen, right? There are various data coming from various sources like health checks, monitoring, logging, and tracing. So all these things, uh, okay, will standardize the cloud native deployments, and based on those logins, you can come up or you can create your own frameworks to make sure your environment is up 24/7. Okay, and now again you will get metrics, events, logging, and traces. So all these things, whatever you have seen in the last slide, right? All these things fall under observability. So metrics, events, logs, and traces. Okay. So that is what user observability is. So observability is not only monitoring; it is it has lot of other data such as metrics, events, logs, and traces. Okay. Now let's move on to the telemetry. Telemetry, okay, is a automatic collection and transmission of data to a centralized location for subsequent analysis. Okay, so telemetry is something like collection of data, okay, which is stored in a centralized location for a subsequent analysis. Like if you want to analysis your environment, you can do that by using the telemetry. Okay, Kubernetes has built-in telemetry capabilities like heapster. Okay, but it's likely telemetry but it's more likely telemetry is provided by other systems that integrates with Kubernetes control plane. So not only heapster, there are a lot of telemetry tools. So as I said, right, there are lots and lots of tools which you can use it in open source world. Okay, so it depends upon the architecture or the architect who defines what tools to be used in the environment, especially in the cloud native. So as of now, Kubernetes has a built-in telemetry capabilities which is called heapster. If you don't want to use this, or if you want to use any sort of third party telemetry, yes, you can use that telemetry as well. Okay, so it depends upon the environment, and it depends upon how you want to use. The best example for telemetry is a weather station. Okay, so where every station will measures the temperature, humidity, wind speed, and all those capabilities, and then transmits the data to the other location or the main office, right? The same thing is applied here. So this heapster as an example, right, will be helped to gather the data and sends that information to a centralized location, and based on that it can perform some activities, or it can do some analysis on that particular data which it has gathered from the telemetry. Okay, now again, in telemetry, the data is divided into three categories: logs, metrics, and traces. Both observability and telemetry has same category, that is logs, metrics, and traces. Again, logs, again, I don't have to define what a log is, right? Whether it is errors, warnings, debugs, or information, everything will be saved in logs so that it will be easy for us to troubleshoot whether it is an application issue or whether it can be a infrastructure issue. A simple log entry could be start and end of a specific task that the application is performed. So whenever there is an activity performed on an application, that activity will be logged into the logs. Okay, if there is any error, even the error will be logged. Whether it is error, warning, debug, or information, everything will be logged into a application logs. Okay, now metrics. So metrics again are quantitative measurements taken over time. So you know these the simple example of metrics is um, in Linux you might have used uptime commands, right? Uptime command. So what uptime command will do? It will give you the usage for 5, 10, and 15 minutes. So how it got that 5, 10, 15 minutes utilization? Because somewhere it saves that information. So that is nothing but your metrics. So metrics is nothing but the date collected data taken over a particular period of time, and with a subsequent interval of time it takes the data. So that is how the metrics data will be collected, okay, with a regular interval of time. And traces, that they track the progression of the request while it is passing through the system. So as I told you, right, the best example is when you create a pod, it goes through the entire process, right, through API, scheduler, kubelet, docker, and all those things, right? So this entire pass through from API to Docker will be tracked, and which will be maintained by the traces. Okay, and then traces are used in a distributed system that can provide information about when a request was processed by a service and how long will it took. So what happens is sometimes at times your environment might be slow. Okay, though you don't have a load on the environment, your the platform might be slow. So in that case, right, you might not know where exactly is the problem. So what you do is to identify that, right, you can create some resources like creating pod, whatever you want. And when you have the traces, right, in the traces you can easily find out how long did it take to create that resource, whether it can be a pod deployment or container, sorry, or a storage or whatever it is. So if it is taking a longer time to create a resource, right, yes, then there is a problem with some APIs. So we need to work with vendors to see to or to fix that issue. So that traces will help you to deep dive into the problem, and uh, understand more about that issue, so that you can isolate that particular issue whenever you have that traces in place.
So, guys, this was our expert from Team K21 Academy. And if in case you missed upon any concepts or if you want to dive deeper, then we have something really, really special for you. We have our free class on Docker and Kubernetes certification to get you higher paying jobs. And in this interactive session, we'll be learning about why learn containers, that is Dockers and Kubernetes. We'll be learning about the whole Docker container architecture. We'll be getting to know about some hands-on demo. We'll be getting to know the certifications regarding Kubernetes, CKA, CKS, and CKAD. And we do have Q&As along with a limited time gift. So if you want to enroll for this free class, all you have to do is just log on to k21academy.com/K8S02. And after that, you just have to click on book your free seat now. And After that, you just have to select an event date according to your availability, add your name, your email address, your phone number, and click on Yes, Save My Seat. Moving ahead, you'll be seeing this kind of URL. You can add this URL to your calendars, and I'll see you in the free class. Till then, take care and keep learning.